Hello everyone, and now we are going to look at the convolution example. So let's first draw these signals. So signal x of t is basically, you can see that there are two signals in it. So let me very quickly plot them separately first. So the first signal in x of t is basically e raised to power 2t, e raised to power 2t. So recall from chapter number 1, this is basically a rising exponential. Okay, so the signal is a rising exponential like this, and at t is equal to 0 the value is 1. And then there is another signal which is u of minus t. So let me plot that as well. So u of minus t, and recall it that this is again a unit step signal, but it is time reversal unit step signal, which means that the signal is like this. Okay, and then these two signals are being multiplied, which means that you're going to get only the part on the left hand side of this particular signal. So x of t signal is basically this one. So so this is the signal x of t, and then on the right hand side the signal is 0. Okay, and this peak is at 1 and this is 0. So this is your x of t. Okay, and then I need also h of t to plot, and we can do that very quickly as well, because we know that this is a unit step signal, and it's a unit step signal shifted towards right and starting from 3. Okay, so this is the signal. Okay guys, so now let me write down the convolution integral. So the convolution integral is minus infinity to infinity x of tau h of t minus tau d tau, and let me write it like this, minus tau plus t. So we are clear that t is the shifting parameter, okay, because this side is written in terms of a tau variable. Okay, so now I need x of tau and h of tau. So I have told you guys before that you simply change the variable over here and write tau over here. So now you have x of tau and you have h of tau as well. Okay, so x of tau is there, and now I need to plot h of minus tau plus t. Okay, so let's plot h of minus tau first. H of minus tau. So h of minus tau is going to be that this 3 point is going to be at minus 3, and the signal is going to be reversed. So this is a time reversal, as you can see. And now we are going to plot h of minus tau plus t with a shift. So let's plot that. So tau and h of minus tau plus t. Okay guys, so this is an interesting example, because what we have discussed so far, that once you flip it, you need to take it to a point when there is no overlap between two signals. But now you can see that this particular signal, irrespective of what the value of t is, there is always going to be some overlap. Okay, so let me first plot h of minus tau plus t for condition t less than 0. Okay, let me first plot this thing. So we know that what we are going to get is this thing. Okay, and then 0 point is going to be at t, and this minus 3 point is going to be at t minus 3. Okay guys, this is an important bit. So this is the t point, which was 0 point, minus 3 is at t minus 3, and this is 0. Okay, so when I say that t is less than 0, this means that this point is less than 0. Okay, so now you can see that there's always going to be some overlap. What do I mean by that? The signal x of tau has values from minus infinity to 0, whereas h of minus tau plus t for t less than 0 also has values from minus infinity to t minus 3 to t minus 3 to this point. Okay, so now on the left hand side, the first condition is that we need to make sure that this signal is on the left hand side. So this t minus 3 should be less than 0, not t less than 0 if you want this signal to be on the left hand side. Okay, so the first condition is, which we are going to write, is that we are going to write for t minus 3 less than 0, which means t is less than 3. This basically means that this point, t minus 3 point, is on left hand side. It is somewhere over here. And then the convolution is y of t. So we need to write the range now where there is an overlap. So if you look closely now, let me plot the other signal on this. The other signal is like this. Okay, this is your second signal. So what you can see is that the overlap is always from minus infinity to t minus 3. That is the range of the overlap, not 0, because this particular signal is defined till t minus 3. So the range of the integral is from minus infinity to t minus 3. Okay, guys. And then you need to write the x of tau. So when you change the variable, also change the variable on this side. So this is going to become now e raised to power 2 tau. Then this is u minus tau and its value is 1. And then u of tau minus 3, its value is also 1. So this is the integral which you need to solve. Okay. And if you want to solve, I will quickly solve it. So this is now 1 upon 2 and e raised to power 2 tau, and you need to substitute the limits over here, and then this is going to be 1 upon 2 e raised to power 2 t minus 3 minus e raised to power 2 minus infinity, and then this term is 0, and the answer is simply 1 upon 2 e raised to power 2 t minus 3. So this is the convolution result for t less than 3. Okay, so let's move ahead and plot it again. So now what I'm going to do, I'm trying to bring this signal towards the right side. Okay, that is what I'm planning to do right now. So let's plot the signal again. Tau h of minus tau plus t. So what I want is that this particular point, which is at t minus 3, should be on the right hand side. So in order to do that, the condition is that now that t minus 3 should be greater than 0. So if this is the case, then my signal is something like this. So now my signal is like this. Remember, this point is t minus 3. So t minus 3 is now greater than 0. Okay, so I have moved my signal towards the right side. So the other signal is let me plot the other signal. The other signal was this one. Okay, this one. So now if you want to find out the overlap again, so you can see that the both signals have an overlap from minus infinity to 0.0, not t minus 3, because the signal x of tau, the red one, is not defined over that side. So the overlap is from minus infinity to 0. So let's compute the remaining part. So now for t minus 3 greater than 0, or t greater than equal to 3, y of t is from minus infinity to 0. That is where the overlap is, minus infinity to 0, and then the same thing, e raised to power minus 2 tau d tau. And now if you solve it again, so the answer is going to be 1 upon 2 e raised to power 2 tau, 0 and minus infinity, and this is going to give you answer of 1 upon 2. Okay, so finally the convolution result is y upon yt is equal to 1 upon 2 e raised to power 2t minus 3 for t less than 3, and then for t greater than equal to 3, the answer is 1 upon 2. And finally you need to plot it. So let's plot it and conclude this example. So this is t y of t 0, and let's take a point over here 3. So for t equal to or greater than 3, the value is 1 by 2, which means it's a straight line. Okay, and this amplitude is 1 by 2. And then for less than 3, what we can see is that this is basically e raised to power 2t. If I write this expression over, if I open up this expression, then this is basically 1 upon 2 e raised to power minus 6 e raised to power 2t. Okay, so this is some constant value, and then this is a rising exponential e raised to power 2t. So what does that mean? That for the remaining value, I'm going to have a rising exponential, and at t is equal to 3, e raised to power 0 is 1. So at t is equal to 3, the value is going to be 1 upon 2, which is this point. So the final curve is going to be something like this, rising exponential and meeting at t is equal to 3. Okay, so this is the your convolution integral result y of t plotted now. So I hope this would be clear. So this is a particularly interesting example because even when we uh, flipped it and moved it towards left side and tried to take it to a point where there is no overlap, it wasn't possible because my other signal was basically defined on the left hand side, so there was always an overlap. Okay, so this is an interesting example, and I took this example to explain this particular concept. So just in case if you guys are wondering, this is an example of the Oppenheim. Let me very quickly confirm the example number. So if someone wants to later on view it, they can view it on their own time. So let me confirm. So guys, this is the example number 2.8. Okay, so this is example 2.8 of Oppenheim. So if you want to review it, or if you want to have a further, if you want to have a read, so you can always go into the book and look over there as well. So see you in the next video. Thank you.